Hello. So today I'll be talking about how to the C++ API for how to build LLVM IR. If you haven't watched my video on reading LLVM IR, I would recommend you also do that. It'll be in the same playlist. So LLVM IR breaks down all of its data into effectively two big type hierarchies. There's the value hierarchy and the type hierarchy. The type hierarchy, as you'll notice, is rather small, modestly sized. It contains things like integer types, function types, structs, so on. Notice all of these are types. So wherever a type is required, you can generally pass one of these. However, values are more important. And as such, they have larger class hierarchies. You have things like say constants, or particular instructions can be values because you could assign from them, like say phi nodes or certain comparison instructions or other binary operations. You can also have certain operators that may be useful. But this isn't just all that's possible with values. You may notice that constants here can be a bit larger. You can have, say, functions that are values because you pass function pointers, or say you have global variables, or you have global constants of some sort. So values are a very complex tree. And to create them, we can talk about the three LLVM classes you will need to use in order to build any LLVM, in order to build any front end on top of LLVM. The first is an LLVM context. Now, an LLVM context is very light. It doesn't have a complicated hierarchy and it doesn't have that many functions. But what it does do is it provides all of the types you'll need. As you'll notice with a lot of these types, they are bound to a context. They contain a context within them. Because most of the time you pass these by pointer, and contexts actually own the value. So from a context you can get all the types, but contexts don't store any values. So you'll have, say, you'll have say modules. The modules can actually take a context, but they do store values. However, it's not easy to store values within a module. You'll notice that you can get values out of a module really easily, but to add values to a module can be a bit trickier, especially when there's, as we saw, so many different types of values that you may want to add. So LLVM, being nice, provides an IR builder. Now, here we are looking at the IR base builder, the IR builder base, but most of the time you won't be directly working with this. You'll instead be working with a derived class that is the IR builder. And you notice a plethora of constructors that we have. We can point it at a basic block, we can point it at a context, and so on. But in reality, what we'll want is something like this, where we can insert instructions or insert constants, or even better is create certain instructions. And not just complex instructions like, say, memset or memcopy, but even simpler instructions like, say, call the bevy of call instructions, return instructions, and so on. And even some very precise integer instructions like signed division or multiplication. Now, once we get to that, there are roughly three ways. Now, elaborating on that further, we have first the IR builder here, which is a way to create instructions. The second way is that a lot of these instructions will have generic, some values may not be found here. You may have to use generic creates on them, like say functions. When you have a function, as we'll see down in the constant tree, function is a type of value, but there's not, I haven't noticed really a nice way to create functions here. So let's see if we can search one up. Create function. There is no create functions. How do you create functions? Well, let's ask the module. Maybe modules can create functions. Let's see what we have for functions. Let's see what we have for function. We'll notice that we can always get a function from a module, but we can't create one. And so here we have all sorts of attributes on functions, but if we scroll down just a bit further, we have creates on functions. So for example, we are creating a function with a particular type, a particular linkage, particular name, and so on. Now, if this doesn't pan out, which in certain cases it may not, some types may not provide a nice create function, we can always just manually allocate a pointer and then pass it into LLVM and assume that LLVM will handle the lifetime. Now, while this is the least preferred way, there are some types which do not have the ability, the nice create function or a nice IR builder interface for them. So the way to start out with this system is to make the context, then to make a module around that context, then to create an instruction for that create an instruction builder, and then call the instruction builder and effectively build up the IR that way. Now, if you're building from, say, a syntax tree, Lang in particular uses the visitor pattern, which allows the syntax tree to just be a tree of data, and a class called a visitor walks over that tree in whatever order it prefers to actually generate this IR. That we can get into in a later episode. I will be providing a resource at the bottom for a small example program that uses LLVM, that shows how to do a very minuscule LLVM module that will effectively do very, very close to nothing, but it will at least show the framework around the whole system. Thank you.